Hi, this is King of Review. Here we have to solve an equation with logs, where the solutions are the same as the equation without logs over here on the right. Now we don't know the base of the logs yet, that's what we're trying to find, so I'm going to start by solving the equation on the right. It's a quadratic equation, the highest exponent is 2, so a nice easy way to solve it would be by factoring. I know x times x is x squared, I need two numbers that multiply to 27 and add up to negative 12. Well, negative 3 times negative 9 is 27, and those two add up to negative 12. So I know that either x minus 3 is equal to 0, or x minus 9 is equal to 0, and I get that my two possible solutions are x equals 3 or x equals 9. So I know that's what I'm looking for. But now let's return to this logarithmic equation. I have a log base a in the first term that's squared, and a log base a of x to the third in the second term. If I could get rid of this third power, I would have exactly the same log in both terms. So I'm going to use a property of logs that says if you have the log base b of x to the a power, that's the same thing as a times the log base b of x. You can basically take the exponent and move it to the front of the log. So if I use that in the second term of my log equation here, I take the 3, move it to the front of the log, and I get 3 times the log base a of x. Now, since I have the log base a of x in the first term and in the second term, let's simplify this equation by introducing a variable y, and let's set that equal to the log base a of x. Now I can substitute y anywhere I see the log base a of x in my equation. So we get 2y squared minus 3y plus 1 equals 0. This is another quadratic equation that we can now factor. 2y times y is y squared. We need two numbers here that will multiply to give us 1. The only two whole numbers that do that are 1s. We need them to multiply to positive 1, but add up to a negative. To make that work, they would both have to be negative. They will multiply to give us a positive, but add up to give us a negative. So I can solve this the same way. 2y minus 1 equals 0, or y minus 1 equals 0. Solving for y, I get y equals 1/2, or y equals 1. But now I need to turn this back into a problem about x. So let's replace y with the log base a of x. We know it has to equal 1/2, or the log base a of x equals 1. Now I need to solve for x so I can compare it to my solution over here on the right. So let's use another property of logs that says if you have some base b and you raise it to the power log base b of x, b is now the base of an exponent and a log. Those two are inverses so they cancel each other out, and we're just left with the power x. So let's see what happens here. If I take a, the base of my log, and raise it to the power of both sides of both equations, here's what we have. A to the power log base a cancels out, we just have x. A to the 1/2 can also be written as the square root of a. On the other equation, I again have a to the log base a, those cancel, and I just have x. A to the first power is a. So now I have two different solutions, x equals the square root of a, or a, and x equals 3 or 9. So I need a number for a where one possible solution for x is just a itself, and the other solution is the square root of that number. Well, I know that 3 is the square root of 9, so if I say a is 9, then the other solution would be the square root of 9, which is 3. And those are exactly the two solutions I want. So I know a must be 9. And that's it. Thanks for watching.